Okay, so I live in Kent, Garden of England, and of course we're having some beautiful weather, and it occurred to me to build a canoe and go for little canoe trips up and down on the river. Now luckily, I have the wisdom of ignorance. Basically, I've got no idea what I'm doing, so I'm too stupid to know to be afraid of it. And that goes with the idea that if you're stubborn, determined, and happy to get things wrong, then you're gonna be able to do, well, just about anything, really. Now, whenever you think about doing something, of course, there's always a million versions of it. And if you're thinking about building something like a canoe, well, you're going to have at least a billion versions to choose from. And to be honest, the hardest thing is just to make a choice. And just make a choice. Yeah, it can be the wrong choice, maybe, but have a look in your area, see what there is. I like this. It's the kind of thing that I'm actually thinking about, sort of a cross between traditional and modern, really, with modern materials. It has a beautiful look to me. So this is the kind of thing that I'm looking at. But of course there are other things, and it's really just a question of what you want to choose. I want to choose this. I mean, let's face it, what could be better than pottering up and down on a river on a beautiful sunny day? Now, of course, if I want a canoe, I can just go out and buy one. I mean, basically, there are loads of them around, and there's a canoe to suit every single budget. So, why not? Well, I also have this other theory. I think that if you put a bit of you into something, you value it more. And so my first view is always to try and build something. I think by building it, I have more than just ownership. There's a bit of me in there, which means it's more mine, so to speak. I understand people don't have time and they have other considerations. That's just how I feel about things. So I turn to making it myself. Now, of course, when you're going to do something like that, in fact, when you're going to do something like anything, there's always a million ways you can make it. I mean, boat building, well, you can do it in wood, you can do it in plastic, you can even do it in stone if you like. There's a style called ferro cement. It's a whole range of doing these things, and I've chosen to try and 3D print it. I'm not sure I'm going to be able to achieve that, but that's what I'm thinking. I'm thinking, okay, we're going to 3D print it. So the first thing we need to do, of course, is create the model for the 3D print. And again, there are ways to do this. I mean, I could get an original canoe, scan it, I could measure it, or I could turn to a set of plans. And I happen to have this thing, which is called Canoe Craft by Ted Moores and Marilyn Moore. It's an awesome book, but in the book, there are some plans for various types of canoes, along with all the information I need to create my 3D model. And I've chosen something called the Peterborough. I'm going to take these bits of information and turn it into a 3D model so I can look at 3D printing my own canoe. So this is what we're going to attempt to draw, and we're going to attempt to draw this on FreeCAD, and we're going to use something called Curves Workbench. Now in real life what you do is you draw all these frames out and set them up at set distances along something called a strongback, and they're usually made out of timber with some kind of distance, and it's usually scrap timber, and the whole lot is joined up with springy bits of wood to give you these very nice curves. Now in order to draw these shapes, what we've got are these two tables of information giving us distances from a centre line that will help us draw out each of these frames and then place the frames along a strongback. So we're going to pretty much copy what they do in real life, and that process is called lofting. So we're going to loft these into FreeCAD Curves Workbench to create this skeletal framework. So we've got FreeCAD open. Now it's unlikely you'll have the Curves Workbench, so you'll need to add it. Look in Tools, go to Add-on Manager right there, and it'll pull up this screen for you, and what we need to do is just scroll down to the workbench that we want. And you might want to explore this because there's absolutely tons of them. If we go to the Curves Workbench, there it is, and then we can click Install. We need to restart it, and when we've restarted it, if we click on this workbench, we'll see that we've added curves, and that'll take us to the Curves Workbench. Now, it may actually surprise you if you're not into boat building. What they do in real life when they're taking some boat plans and turning it into a boat is they essentially get a big bit of graph paper and put these measurements on the graph paper. cut it out, paste it on the bit of wood, drive in some nails, and then push a spendy stick around the nails and draw around it. That process is called lofting. And essentially, of course, what we want to do is exactly the same thing, only we need to do it in FreeCAD. So we are, if you like, creating a bit of graph paper, putting points on the graph paper, which will be the same as the nails, and then we'll use a curve from the curves workbench instead of a bendy stick and put a curve around those points. Right, annoyingly for me at least, all of my measurements are actually in inches because it's an American book and I need to have this in inches. But if we go here, we can click on that and you can see that you can change your standard quite easily. I used millimeters before and here now I've put it into US customary inches and pounds. So now my measurements will be in inches if I've got that highlighted. So I can jump to my file. I need to create a sketch into unnamed. So we create a sketch by hitting sketches. The sketch needs to be in the XZ plane. You've got to imagine as if you're looking down on the canoe. Normally you're looking at the top down, which is the XY plane, and here we're looking at the front back, which is the XZ plane. So we create it in the XZ plane and click OK, and we'll get this as our sketch screen. The first thing we want to do is set up the graph paper, if you like. Now, pretty much a standard, and certainly on these measurements that I've got, the distances from the center line and the baseline are 2 inches. So I need to create a set of lines 2 inches apart that will represent my graph paper. They only go 14 inches up, so from 0 to 14 is the number of steps that I need. And of course, that's going to be 8 points. So we go to Polyline, which is right here, and randomly place 8 points, starting at the origin, on this line here. Now what we want to do is select the lines, and we need to put an equals constraint on them so they're all same size. We want to make them 2 inches, so hit dimension, the first point up, click on it and type in 2. It will automatically adjust so all of those things are 2 inches. Let's change the view. And we can see we've got a range of points now 2 inches apart. What we need to do now is create exactly the same thing but along this line here. So again, the polyline, and it's starting at the origin, place 8 points. Select the lines and place an equals constraint on them. Then we need to dimension it yet again at 2 inches when they'll all be changed to 2 inches. So click the dimension, use this, type 2, hit OK, change our view. So now we've got our graph paper, and of course what we want now are the points that are on our charts. Starting from chart B, click on the line tool, go to the top point, which is the 14-inch point, and you can count that up and just draw a random line. When you read it on the chart at 14, you'll see that the chart says it should be 14 and 11/16 long, and you type that in. 14, and of course 11/16 is 0.6875. And when we hit enter, we get our first point, and now we have to repeat that for all of the other points. So that is chart B going out from the center line, placing the points where we need them to be at 2-inch intervals and this many inches out. Now we need to do the same thing, but going up from the baseline, and this is the baseline here. So this time we use chart A, measuring up from the baseline, and we'll start at 14 inches, which is that point there, and this should be 3 3/4. So again, grab a line, move it up to some random distance, type in the 3 3/4, which of course is 3.75, tab 90 now, so it's straight up, and enter, and then we get our next point, and our next point now is from chart A, and we continue with that along the rest of these. Right, here it is with all the points drawn where they should be, and now I can close it. When I close it, we jump to sketch here. Now, if I look at this bit from data to view, what we can see is that we've got point size. If we change that point size to 10, or just something bigger than 4, what it'll do is make the points bigger. Making the points bigger is really cool because now that makes them easy to select. So to select them, when you want a multiple selection, hold down the Control key and select it. When we've selected them all, we can hit the curves workbench, and it's this one, an interpolate curve we want. Click on that, and we've drawn our curve. That's just like our bendy stick. So we only did half of it because, of course, the other half is just the mirror of what we just did, so we can mirror it. Unfortunately, of course, we do have to do another 7, but there are a couple of tricks to make that a bit easier. The first one is to create a group. Click on Canoe Body, right-hand click, and you'll see Create Group, and it'll create one called Group. Double-click on it, and you can rename it. Rename it to something like Section 1. Now we can drag things into it. So we can drag this sketch into it, and we can drag the interpolation curve into it. Then if we copy that, Control-C, Control-V, then we'll copy everything in Section 1 and create a new group called Section 2. And of course, anything in that group will do exactly that. And then, of course, paste it. And we get Section 2, which is an exact copy of Section 1. So if we hide Section 1 and its sketch, we'll see Section 2 in its sketch, which is what we've got there. If we click on the task for Section 2, then what we can do directly is change these numbers. So we can just double click on the number, it will come up, and now we can go back to the charts and overtype on Section 2 the information needed for Section 2. Repeat that to create all of the sections that we need from Sections 1 to 8. Now here's the really neat trick, or at least I think it's neat. If we show sketch, because these are all there, remember, and if we show sketch, that's the original sketch that we had. And so we've got the sketch of the lines and we've got the curve along with it. If we show sketch, the next sketch, it creates that sketch and you can see it here in blue. If we're on sketch and we have a look at data, go to placement, you'll see position. Click down in position and we're on the y-axis because remember we made this so that it would move along the y-axis, and it is in inches. Now, traditionally, these stations for canoes are placed 12 inches apart. So all we have to do is move that to 12 inches. And it moves the curve along with it. So now if we're looking at this, we can see that what we've done is create the two stations 12 inches apart as if they were on a strong back. And we can do that with all of the other sections. Now in traditional boat building, this all gets cut out of wood with nails and bits of stick, and you cut out those shapes. Then you set those shapes on basically a big slab of timber that's going to be as long as the boat you want to make, and you set them up at 90 degrees so they make a kind of skeleton. That big slab of wood that you nail everything to is called the strongback, because what we're doing is using a concept of the strongback in order to be able to arrange those things as we would in real life. So we just continue with that, setting those frames up on the virtual strongback. So when we've done that, we get a ghost of our canoe. So we can see the ribs there, all the curves. Now I've taken the curves just by themselves so we get the idea of what the ghost is. But we can create more curves. So if you look over here, you'll see that the eye is showing to show the curve. And on the sketch, it's actually blanked through. If I click on that blank through, the underlying sketch along with its points will show up. If I do that on all of those, then we get a messy sketch to look at, but we get all of the points that we're now going to need. So we go down the whole thing and open up the eyes so that we can see all of those sketches. There we go. If you think about it, we've done nothing more yet than what we would do in normal boat building. We've taken our plans and our bit of graph paper and we've positioned the points accurately on the graph paper, and we did that with Sketcher and just defined the points. Then we jumped to the curves workbench and we drew a curve around those points by highlighting them. Of course, in real boat building, you drive nails in a bit of wood and use a bit of bended stick, but we've done exactly the same thing. Then we jumped to the parts workbench and we arranged those stations that we made along a strong back so they created a framework for our boat. And as I say, this is identical with what happens in real boat building. Of course, the very next thing we need to do is put a skin on there. Now, in real boat building, what they do is lay on planks of wood on something like this, which is a strip canoe, it's a cedar strip canoe. Those are little cedar strips with rounded ends and cups on the other side, and you pop those onto that framework and glue on, nail or fasten them temporarily in place till the whole thing sets, and that's how you build your canoe. Of course, we've now got to put a skin onto those frameworks that we've got, and in something like FreeCAD or any other 3D imaging program, drawing program, there's loads of ways of doing that, but there's one particularly easy way in the parts workbench called lofting. So here we are in the part workbench with all of our curves showing. And we created those curves with that curves workbench. Now we're here, we can see them all in place without the sketches, although I can put the sketches back just by undoing the eye and the sketch will pop back in place because it's still there. We're just looking at the curves, and these are the curves we created in the curves workbench. Now we want to skin those, and the tool that we want is right here, it's there. And that's called the lofting tool. If we click on the lofting tool, then we get this pull-up box. What we want is every curve that we created. So if we just click on the curve and the arrow, it will turn it into this selected profile, or rather move it into the selected profile. So click on all of those and move them into the profile section, and then we're ready to loft. And lofting will create a skin between those profiles. Notice we can create a solid if we want to as well. If we click OK, hey presto, it creates a skinned version of our canoe ribs. So now we've got a canoe that's actually got a skin on it. And that is a quarter of our canoe. Of course, what we want to do now is make the entire canoe. And to make the entire canoe, we use this tool here, which is the mirroring tool. To actually mirror it, click on it to select it, click on the mirroring tool, and here you get a choice of planes. What we want to mirror it on is the YZ plane. Once we've selected the YZ plane, click OK, and we've created the other half of our canoes. It couldn't be easier than that. Of course, this gives us a half instead of a quarter. So now what we want to do is select both of them by clicking on Loft Mirror and Loft, and we mirror it again. So hit the mirroring key, and this time we want to mirror it on the XZ plane. Click that and click OK. And now, if we look at the view, we have our entire canoe all skinned and ready to go. We can export that now as an STL file if we wanted to. So that first bit where we had to lay out all the points, that was, to be honest, a little bit tedious. The next bit where we popped the curves on was kind of cool, but that last bit where we skinned it and mirrored it, well, that was just like magic, how you just bang, and there's what you wanted right in front of you. Now, of course, I appreciate you may not be interested in building a canoe, but this technique of lofting is incredibly useful for a whole range of things, not only canoes and boats, but things like aircraft fuselage, propellers, and of course, wind turbine blades. So that extra workbench, the curves workbench, it's well worth getting to grips with, particularly if you want to do something that's a bit more organic and has been cut into slices that you can arrange and then skin and then print. Now, of course, I have now a full-size model of a real canoe, and I've got to think about how I'm going to actually get this out of the STL and print it in real life, because printing this on a 3D printer is going to be its own challenge. Now, I do have the Elegoo Orange Stone Giga, So I will be able to print that without a doubt. On a smaller printer, I think it'll be a bit more challenging. Still, as an exercise on how to use the Workbench, particularly if you're interested in other things like wind turbine blades, I thought it was well worth going through. I hope you enjoyed the video. Thank you very much for watching, and please do remember to like and subscribe.